My dear students, today we'll discuss a few more concepts related to interfacing of 8051 microcontroller with other components, that is DAC interfacing. Afterwards, we'll discuss about the 8051 microcontroller interfacing to the stepper motor. DAC means what? That is digital to analog converter. In the previous video lecture, we have discussed about the interfacing of ADC, that is analog to digital converter, with the 8051. Today we will discuss about how can we interface the digital to analog converter to the 8051 microcontroller. Sometimes what happens, suppose we want to control some the analog devices like some induction motor, at that time induction motor and other motors which will work on analog signals, analog voltages. At that time, to control that one, we use the microcontroller, and we use Atmel 89C51 microcontroller or some microcontroller related to 8051 microcontroller. Suppose we want to control the speed of the induction motor, and suppose the speed exceeds 1000 rpm, then automatically stop of the induction motor. And for example, if voltage exceeds 230 volt, automatically stop the induction motor. If current exceeds, for example 5 ampere, then automatically stop working of the induction motor. That all control activities will be done with the help of the 8051 microcontroller. That is in MTech we have done that one. That is we have used the embedded based PWM inverter to drive induction motor and speed control by varying duty cycle control. In that we use the Atmel 89C51 microcontroller. Using that we can control the speed of the induction motor and also protect the induction motor. How it will protect the microcontroller? Atmel 89C51 microcontroller is there, no, that will control all the activities, not only the induction motor. You can simultaneously it can control all the devices which are interfaced to the microcontroller. For example, induction motor, you may make simultaneously, you may be connected LCD display. Other devices also interface to microcontroller. At the same time, it will control all the activities. If the speed of the induction motor exceeds 1000 rpm, it automatically stops working of induction motor. If current exceeds 5 ampere, automatically stop working of the induction motor. If voltage exceeds 230 volt, automatically stops the induction motor. How it? Because in the program we have written like that. That is, if the speed of the motor exceeds 1000 rpm, stop the induction motor. If voltage exceeds 230 volt, automatically stop the induction motor. If current exceeds, example, 5 amperes, automatically. According to that program, and we are dumped into or we stored into the ROM of 8051, that program will control all the devices which are interfaced to the microcontroller. Induction motor for that, how we can control? For to control that, we have to give the signal to that. At that time, using the DAC, some digital to analog converter we have to use, so that we can interface the induction motor with the 8051 microcontroller using the DAC. Because DAC signals which are there in the microcontroller are in digital form. Whatever signal it gives, it is also in the form of digital. But suppose we want to give those signals, we want to control the analog components. At that time, we have to use the digital to analog converter. Digital to analog converter means which will convert the digital signal to analog signal. That is digital. You know that digital signal means which is in the form of 0, 1, 0, in the form of zeros and ones. Analog means it is in continuous in nature. For example, sine wave in an example for the analog signal. Like this, analog to convert that one digital signal or digital data. Signal may be different, data may be different. Signal means a signal entity which contains information we call as signal, whereas data It's data. Some this soft copy. This is nothing but data. Some data you want to transmit, some numbers, some soft copy of this. This is nothing but the data, whatever we want to transmit. We want to store some files, everything. That is nothing but data. It is not a signal. So we want to store some numbers, some program. That will be considered as data. Signal means some which contains some information. Therefore, this is how we can. Therefore, we have to interface the digital to analog converter with the 8051. At that time, we can use some ICs are there. That is MC1408 DAC or DAC 080. Some ICs are there. Those ICs integrated chip, what they will do, they're used for interfacing of 8051. Here they are DAC is 0808 microcontroller. Sorry, this is the what digital to analog converter. Here we have that is DAC. It is here we can use this formula and they are given in the diagram. That is how we can convert the whatever information is there, whatever information is there in digital form, which is there in the 8051, will give to the DAC, and this DAC, what it will do, it will convert digital information, digital signal into analog signal, digital data information into unlock information. That is using this is here while in previous third semester or first semester we have discussed about what is track. So some here they have given some ladder type of technique are used here somewhere they have given there are so many different types of DAC are there which will work as how we can convert that one. The common ones are 8, 10 and 12 bits. The number inputs decides the resolution of the DAC. Since the number, that is how we can convert when we were I think when we were studying in B or MTech, exactly I don't know, we have studied about so many different types of the components, the devices, how we can convert digital to analog, digital signal to analog, how we can convert, what is the technique, everything we have studied. Here they have mentioned somewhere, I'm not finding that one. This is the equation how we can calculate the that is whatever it is 8 bit, it is a 8 bit. This digital inputs are converted into current and connected to the pin. We convert result of the total current provided here. We'll get the current and we have set the I reference as 12 milliampere. Then these are the bits we give to the, here you see here the bits we give to from microcontroller to the DAC, where if all are 1, even though all are 1, then 1 by 2, 1 by 4, 1 by 8, when we add that one, this is 2, and the result will be always less than the reference. This is 1.99 milliampere. It will be always less than the reference current. That is reference current is 2 milliampere. How much this is? 1.99 milliampere. That is we set the reference voltage current here, and even though all bits are 1, then that will be less than the reference current. And voltage, how we will get the voltage? But current into the resistor, it will give the voltage. How we will get the voltage, unlock current from afterwards interfacing with the DAC. Here they given the diagram how we can interface the 8051 microcontroller with the DAC 0808. That is, here they have given the diagram of this. But here in this book he has not given in detail explanation of how it will convert, how it will transmit the digital data to digital signal to analog signal, and they have not given much explanation about this. This is a diagram. This is a diagram of how it will microcontroller will give the information to DAC, so that DAC will convert the digital signal to analog signal. This is the diagram of interfacing of 8051 microcontroller with digital to analog converter. It is 8051 connection to DAC 0808. Important. In exam, sometimes we ask, explain with need diagram the interfacing of 8051 with digital to analog converter. At that time, what you have to draw this diagram. Important. Here also same read, write those whatever we discussed in the ADC, same concept is also here, but here in this book he has not given in detail explanation of that. Here also VCC is given to 5 volt VCC, 5 volt supply is given to VCC, reference, everything is there. But here in this book he has not given in detail explanation of that. Even though if they ask in the exam, then you have to draw this diagram neatly and write all the components very correctly. Then you have to explain about this. That is I out equal to I reference. Then this is the equation how we can convert the digital data to analog signal. The analog data or analog signal. That is how we can convert that one. Afterwards, we will discuss about next we will discuss about the interfacing of stepper motor with 8051 microcontroller. That is how we can interfacing of stepper motor with 8051 microcontroller. Here, stepper motor interfacing. Stepper motor. Here, stepper motor means it is stepper motor which will rotate. It is a motor. It is a motor that will. Stepper motor is widely used device that translates electrical pulses into mechanical movement. That is motor. What is motor? Motor means which device, a component which will convert electrical signal, electrical power supply to mechanical, which will convert electrical what you call, that is, motor is a device which will convert which will convert electrical signal, not signal, electrical, which will convert electrical power, which will convert electrical to mechanical. That is what I want to say. Suppose here we are using fan. Here we are giving the electrical. It is not a signal. Signal means current does not contain signal. If it contains the information, then we call it as a signal. But here it is current contain. Here we are having the voltage, and that voltage gives the power, some current to the fan, so that it will work. That is, motor is a device which will convert electrical supply to mechanical energy. Now I got that is motor is a device which will convert electrical energy to mechanical energy. We have to use the word term energy, electrical energy to mechanical energy. Electrical energy, here when we have the current, then only we can operate the fan. Fan will rotate when we on the fan. If we don't have the electrical energy, if light is not there, then fan will not work. Therefore, fan is inside the fan. What is there? It is motor is there. What motor will do? It will convert electrical energy to mechanical energy. Like in generator also, it is reverse. There, what will do? Will convert mechanical energy to electrical energy. That is, here also stepper motor is a device which will convert electrical energy to mechanical energy. What is the technique we have adopted here is that here we are having, like here they have shown this one upper diagram here, that is some coils are there, and the center one is in any motor we are having the stator and rotor. Stator and rotor will be there. The stator and rotor uh, at that time using that one to the stator, we have some copper windings here. This diagram, this is your, these are the stators, this is the rotor. Here they have given that one, a stepper motor. uh, Here these are the stator, this is the rotor, and these rotors are what, this rotor is stationary, and this is how these are magnets. This is nothing but the A, B, C, these four stators are there. They are magnetic in nature, and we have given, we have some, if you see the induction motor, if you go to fan repairing shop, at that time you can see the construction inside the fan, what is there, so many copper windings will be there. Due to magnetic effect, induced effect, that is electrical energy is converted into mechanical energy. Therefore here it is rotor, this is stator, and when we go here, suppose I want to rotate this one in anti-clockwise direction. At that time, suppose I give energy to, here they have given, here suppose I want to rotate in anti-clockwise, counterclockwise means anti-clockwise, here clockwise direction. Suppose I want to rotate in anti-clockwise direction. So what that, at the time what I have to do, winding A, winding B 0 0, winding C and winding D I will give 1 1. When I will give winding C and D 1 1, when I will give winding C and D 1 1, at that time what happens? This when it we are given this one, then what it will do? It will attract this whatever this energy is given. It will attract north pole here. Then and here when you give one here, it will, here also north pole is there. North pole, south. Okay, at that time, suppose they are given example of rotor alignment. Suppose we are given here, instead of this diagram, suppose we are given A and B, A and B 1 1. At that time, when we give A and B 1 1, A and B, A and B, here second one. In second one, A and B windings we have given 1 1, say winding C and winding D 0 0. At that time what happens? Winding A is given 1 and this is B also given 1. At that time when we are given the input as 1, then what happens? At that time this will north north, it will repel, whereas south it will attract. Therefore, the shaft, the stator will rotate here. And here to B winding also, we are given the electric. When we are given that, it will SS, that is what south pole repel, whereas north pole attract. Like this rotor, this rotate, like this will rotate. Like we have to give the 1 0 0 1 like this only here to rotate in anti-clockwise direction. Suppose we want to rotate clockwise direction, we have to give the windings as 1 1 0 like this. We have to give. When we go like this, then and continuously we have to give. First, what we have to do? First, we have to give 1 1 to this. Next, we have to give 1 1 to this. At that time, this should be 0. Like giving the inputs to like this. 1 means here coil is there. Coil here also coil is there. When we supply the voltage, then EMF is induced. Because of that, it will attract the opposite poles. We know that magnet attracts opposite poles, repels the same poles. Therefore, so when we given the energy, electrical energy to this magnet through this copper windings, then it will repels also, but it will attract this one. Like the stepper motor rotates. Like first we have to go 1 1 to this, 0 to 0 to this. Next we have to go 1 1 to this, 0 0 to this. Like giving this one alternate. This table is important. From this, how we can generate the signal, how we can make the motor to rotate clockwise direction, anti-clockwise direction. How? What are the where we have to give one winding steps, one winding, 1 0 0 1, 1 1 0 0, 0 1 1 0, 0 0 1 1. Like this, we suppose we give the electrical energy to this, then the stepper motor rotates in the form of step angles. This is how it will rotate. Afterwards, how we can interface? This is a diagram to interface the stepper motor. There is interfacing of stepper, very important. Definitely we'll ask such questions in the exam. Explain with neat diagram the interfacing of stepper motor with 8051 microcontroller. This is your microcontroller. That is microcontroller. Here they have used different microcontroller. Here to that microcontroller we interface the stepper motor. Then through the ULN we have to give through ULN, that is use one power supply for the motor and ULN 2003 and another for 8051. Mainly it is used for because this will be in the digital 1 form, but stepper motor requires 230 voltage, and the current may be 2 ampere, 3 ampere. It requires high voltage, high current, whereas this will microcontroller requires how much voltage? Only 5 volts, it may be 12 volts, that much only. And for that we use that one to isolate between this digital signal to analog, and also give much the current and voltage to the stepper motor. We have used the ULN 2003. Use one power supply for the motor and ULN 2003 and another for 8051. We have to directly, we can't connect a microcontroller to the stepper motor using the ULN 2003. We have to interface the microcontroller to the stepper motor. And that is ULN, that is I forgot that one. That is using this we can give supply to this. Okay, this is diagram is important. That is interfacing, that is 8051 connection to stepper motor. Definitely such questions will be asked. Explain with neat diagram the interfacing of stepper motor with 8051 micro. This is your microcontroller. This is your stepper motor. Using here we have given the power to ULN also. Also we have given the power to here, also we have given the power plus 5 volt. That is, by using this we can interface stepper motor to 8051 microcontroller. Okay, very important questions. Definitely such questions will be asked in the exam. Okay, thank you.